For sure, you're familiar with the terms relative motion and time dilation, or simply the concept of the slower or faster flow of time. In next few minutes, I will explain both. Let's start with relative motion. We will observe the same event from different reference systems. For simplicity, let's look at the same event with 3 different cameras: red, green, and blue. From this perspective, the ball moves in this way, and cameras moves like this. Green camera stands still. Red is moving in the same way as the ball, and blue one goes from left to right. Obviously, the motion of the ball will not be seen as the same in the 3 cameras. Let's look through each camera individually. Green camera. It's up and down, very similar to the motion we call a free fall. Red camera. We can state that the ball is not moving. It's like a moving background. Blue camera. From this reference system, the motion of the ball seems to be along some curved path. This movement is very similar to projectile motion. So, the same event is not seen equally in 3 different reference systems. For the same reason, it seems to us on Earth that the sun is moving and that we are still standing. This is very closely related to the dilation of time, or why somewhere time runs slower or faster. But before I say something about that time dilation, let's look at some other examples and try to figure out the way of the motion of the ball. For example, let's look at this motion through some kind of cave. Can you explain the motion of this particle? Is it stand still? Is it moving up or down? Is it moving along a curvilinear path? You can answer all these questions with both yes and no. The answer depends on the system of reference. From this perspective, it looks like the camera is moving along with the ball through the cave, and it looks like the ball is moving along same or some curvilinear path. However, what if we wiped this cave from the animation? For example, like this. We have a completely different motion now, don't we? We have up and down motion. Okay, and just one more example. Let's look at this motion. Very simple, but very odd. Is there anything you can say about this motion now? Is it up and down, or is it a projectile motion? Of course, it's already clear now that we need to define a reference system. It is obvious from this system that the ball moves up and down and the background moves from right to left. Now, it's time for time dilation. That is, we are looking for an answer to the question why somewhere time goes slower and on the other place goes faster. This is a direct consequence of one of Einstein's postulates that reads: the speed of light is the same in all inertial systems of reference. inertial systems are those that move at a constant speed relative to each other. So, let's go. Let's observe the motion of the light beam in this very simple scene. Let the light beam move from top to bottom, and with S we denote the path that light crosses. Then it takes time for light to cross path S, determined by t equal to S over c. Of course, c is the speed of the light. Let's change things up a bit. Let this platform move at some velocity v. If we move together with this platform, then we can observe that the light again crosses path S and that the time of motion of light t is equal S over c. However, if we do not move with the platform, then we have this case. The light starts from the top when the platform is in this position, and it comes to the bottom when the platform is in this position. So in this case, the path of the light is S prime, which is greater than S. And now comes Einstein's postulate regarding the speed of light. And this is very important. In both cases, for this one and for this one as well, the speed of light is the same and is c. And if the speed is the same and the lengths of the paths are different, then we can only conclude that the times t and t prime have to be different. Now let us, in this system of reference, determine the time t prime required for light to pass from top to bottom. So t prime is equal S prime over c, where S prime is obtained from a right triangle and a finite relation for t prime is this one. With very simple transformations, we can find a connection between t and t prime that reads like this. For example, if the platform was moving at a rate of 0.5 c relative to us, then 1 hour in our system of reference is for someone on the platform about 8 minutes less. Or another example, if the platform was moving 0.99 c relative to us, then an hour for us is just about 8 minutes for someone on the platform. The use of GPS devices confirms that time dilation is included in our daily lives. The clock on satellite is faster about 7 microseconds per day compared to the clocks on Earth. So, greetings, until next time.